Hello guys, in this video we are going to talk about simple RNN. Okay, so here we have this recurrent neural network. So here recurrent means repeating. So we can say in the RNN we have repeating structure, right? And we use this RNN for the sequential data. Sequential data. Okay, so let's take an example to understand this simple RNN. So here we have, suppose this data set, here we have a movie review data set. Here we have movie review data set. In this data set, here we have two classes. Here we have two classes, 0 and 1. Right, so in this data set, we have xi values, which are the reviews, and here we have corresponding yi's, which are the target values. So here we have only two classes, 0 and 1. Suppose here we have this x1 reviews. In this review, here we have few words. We have w1 words, we have w2 words, we have w3 words, and we also have corresponding y1, and similarly we have x2 review. In this x2 review we have few words here, w1, w2, w3, w4, w5. So these are the words we have in this review. Okay, so the length for the each review may be different. So here we have xk reviews. Okay, so let's talk about this first review, x1 review. So here we have this x1 review. In this review, here we have three words, w1, w2 and w3. Three words. Okay, the first thing that we need to do is we need to convert each word into a fixed size vector. So this is our v1 vector, this is v2 and this is v3. Okay, now let's see the architecture for this simple RNN. Okay, so suppose this is our RNN layer. In this RNN layer, we have four units. And here we have this input v1. Okay, suppose this is our t equal to 1. It means this is a timestamp 1. And here we have the weight matrix w. And here we have this output o1. Right. And here we have the second. Here we have the second input v2, but we have the same weight matrix, right? Okay, and this is the same RN layer, and here we have the same number of units we have. Okay, and here we have O2 output. Okay, and here we have the last word, last timestamp, which is v3 here, and we have the same weight matrix here, right? Okay, so here we have the one more weight matrix, which is w dash. Here we have the same w dash matrix. Now we have this O3 output, okay, and this is the same RN layer and with the same number of units. Okay, so if this is the last time step or last word, so we can pass these this O3 into a neural network layer, and here we have the sigmoid function. Okay, and here we have this W double dash weight matrix. And here we have this y hat 3. Right, so y hat 3 is the prediction for the input x1. So y hat 3 is the prediction for the input x1. So how can we find this O3? So O3 we can find simply, here we have this activation function. In this activation function we can pass these two inputs, V3 and this and this O2. So here we have two inputs V3 and the O2. Okay, and we also have the corresponding weights W and W dash. So here W, and then we need to perform matrix multiplication with V3. Then we have here W dash, and here we have this O2, and then we need to add the bias here. This is how we can, this is B1 bias. This is how we can get this O3. Next we can find this y hat. So here we have this sigmoid activation function, and here we have this W double dash weight matrix, and here we have this O3 output, and don't forget to add the bias here. And so this is how we can find this y hat 3, which is our prediction. Right, so this is the architecture for the simple RNN. Right, so here we have three kind of weight matrix. Here we have this W weight matrix, right, and here we have this W dash weight matrix, and here we have this W double dash weight matrix. And so this is the architecture for the simple RNN. Now let's see how can we implement this simple RNN layer. Right. So first we need to create some random data. So we can create the random data with the help of NumPy. np dot random, then we can pass the size here, size 1, 3, 2. Here we have this data. So here we have batch size 1, and here we have 3 time step. This is the first time step, this is the second time step, this is the third time step. And here we have the 2 features. Here we have the 2 features in the each time step. Okay. Now next we have this input layer. Equal input layer. Now, and here we have the shape. The shape is 3, 2, because here we have 3 time steps and the 2, and here we have the 2 features the each time step. Okay guys, so here we can see this is not like the layer after layer. right? So here we have only one layer that repeating itself over the time axis. So this is the t equal to 1 time step, this is the t equal to 2 time step, and this is the t equal to 3 time step. It's a, okay, so here we have only one layer that's repeating itself over the time steps that we have here. Okay, so here we have only one layer. Next here we have this RNN layer. So here we have the simple RNN. Here we have the number of nodes, number of units 4, and here we have this input layer. Okay, so this is the syntax for the syntax to create the model with the help of functional API. Input layer, then we can create the model. So first we need to create the layer, then we can create the model. Here we need to pass the inputs and the output and the outputs. Okay. Then after we have this model summary. So here we have this input layer, and here we have this RNN layer. Okay. Then after we can model dot predict on the data. Okay, so this is the output for the last time step. This is the output for the last time step. So you can see here in this diagram, here we have this O3. Right, so O3 is the output. O3 is the output for the last time step. For the last time step. Right, so here in this code, this is the O3. This is the O3. Right, so O3 is the last. So here O3 is the output of the last time step. Right. Okay. If you want to add a dense layer for the prediction, so we can also add a dense layer. So this is our suppose output layer. If you want to make prediction, so we can add a dense layer, but before we need to import it. So here we have this dense layer, and here we have 1 unit because we want to have 1 output. Okay. If you want to use suppose activation function sigmoid, so you can pass here activation equal to sigmoid. RN layer, and the output layer we have output layer. So here we have this input layer, this RN layer, and here we have this output layer. So now if we run this line, so here we have the single value. Here we have the single value. Okay, so this is how we can implement this RNN, this simple RNN with the help of Keras. Okay, thank you so much guys.